Hey everyone, it's Justin again. This help video is going to provide a walkthrough of the first practice problem in the solving triangles lesson involving variables x, y, and z. If you were unable to answer this practice question, or you just don't feel confident in your understanding of the content, this video is going to be very helpful to you. So in the first practice problem, you were asked to solve the triangle below. Where needed, round angle measures to the nearest degree and side lengths to the nearest tenth. We are given a triangle with one known side length, a right angle, and one known acute angle. When it comes to solving triangles, there are many different ways that you can go about it. However, I recommend that you only use the given information to solve. By only using the given information, you eliminate the possibility of incorrect answers due to rounding. So we could solve this triangle in any order. So let's just go alphabetically and start with x first. We actually don't need to use trig at all to solve for x. I have a triangle with two known angles, so I can just ignore the side lengths and use the triangle sum theorem. The three angles in a triangle will always add up to 180 degrees. And once I have my equation, I can simplify and then solve to find that x equals 63. Let's move on to y next. This time we do need some trig. From the 27-degree angle, x is the opposite side and y is the adjacent side. The trig ratio that uses the opposite and adjacent sides is tangent. Setting up my tangent equation gives me this. 27 degrees is not an angle in either of our special right triangles, so I am going to have to use my calculator here. I'm going to isolate y first so that I can just put one single expression into my calculator to solve this. Since y is in the denominator of the fraction, this is a little bit complex. First, I need to multiply both sides of my equation by y to get it out of that denominator. Then, to get y by itself, I need to divide both sides by the tangent of 27 degrees. That gives me that y is equal to 8 over the tangent of 27 degrees. This expression is what I'm going to put into the calculator. I do that, and my calculator gives me back this decimal as an answer. Remember, this is an approximation because it is rounded at the end. Speaking of rounding, now it's time for me to round my side length to the nearest tenth, and that gives me a final answer of y equals 15.7. There is one variable left to solve for, so let's do it. To solve for z, we're again going to use that 27-degree angle and our known side length of 8. This is going to look very similar to the work that we did to solve for y. The only difference is which sides of the triangle that we're using. 8 is still the opposite side from the 27-degree angle, but this time z is the hypotenuse. Since I have opposite side and hypotenuse, I'm going to use sine as my trig function. Setting up my sine equation gives me this. Now it's time to isolate z so that I can have an expression to put in my calculator. Just like when I solved for y, z is in the denominator here, so to solve, I'm going to need to multiply both sides by z to get it out of the denominator. And then I just need to divide both sides by the sine of 27 degrees to get z by itself. That gives me that z is equal to 8 over the sine of 27 degrees. This expression is what I'm going to put into my calculator, and my calculator gives me back this decimal as an answer. Rounding to the nearest tenth gives me a final answer of z equals 17.6. I'm going to put all three of these answers in my triangle just to give you the full picture. As I mentioned earlier, this is just one way to solve for these three variables. You could have taken many different approaches, but they should all give you 63 for x, 15.7 for y, and 17.6 for z. For all three example problems, there is work shown in the answer key for every possible method of solving. So no matter what approach you take, you should be able to check your work against the key. Good luck on the rest of your practice.